Okay, so we'll be looking at similar triangles, and the concept of similar triangles will bring us into the geometric mean. You're used to having mean, it's the average, but you're used to doing the arithmetic mean and not the geometric mean. Now, right triangle similarity. If I've got a right triangle and then I construct an altitude using a perpendicular segment goes from the base to the highest point, I have three triangles that are all similar to each other. All right, I've got my original triangle ABC, and now because I put that perpendicular altitude in there, we also have triangles ACD, and we got triangle BCD. So let's find the value of our good friend X. Well, if I look at the small triangle, I know the hypotenuse is 3. I know the long leg is X. If I look at the medium triangle, I can tell the hypotenuse is 4. The short leg is 6. That won't work. I've only got the hypotenuse, right? That's only one corresponding part. Let's look at the large triangle. Well, on the large triangle, the hypotenuse is 5, the long leg is 4, and the short leg is 3. Aha! If I look at the large and the small triangle, the hypotenuse is one corresponding part, the long leg is a second corresponding part. Let's put together a proportion and solve it. I know the small triangle's hypotenuse will compare to the large triangle's hypotenuse the same way that the small triangle's long leg will compare to the large triangle's long leg. Plug in the values I know, cross multiply, divide, and now I know X is 2.4. Now, there's another way that I could have done this. I could have said, no, wait. If I look at the medium triangle and the large triangle, I've got the hypotenuse and the short leg. And I could have set the proportion this way, comparing the hypotenuse of the medium triangle to the hypotenuse of the large triangle, the short leg of the medium triangle to the short leg of the large triangle. Cross multiply, divide, and of course I'm going to have the exact same answer. Right? As long as I set up a proportion correctly, I will get the correct answer. Okay, again, let's find your friend and mine, X. Again, if I look at the small triangle, right, KLM, I see the hypotenuse is 5, I see the long leg is X. If I look at the medium triangle, that'd be JKM. Hypotenuse is 12, short leg is X. I've only got the hypotenuse there. All right, just one corresponding part. Let's look at the large triangle. All right, that'd be LMJ, right, the largest. Hypotenuse is 13, long leg is 12, short leg is 5. I'm in business. Not only do I have the hypotenuse matching between the small and the large triangle, I also have the long leg matching. Set up a proportion, cross multiply, divide, or I could have used the medium triangle with the large triangle, because then I'd have both the hypotenuse and the short leg available. I could have set up a proportion, cross multiplied, divided, and of course I'm going to have the same answer. Again, the key is you've got to set up a proportion correctly, right? Pick which two triangles you're going to use, and then make sure you've got two corresponding parts on those two triangles. Now, this one is a little bit trickier. You'll see what happens in a moment. Small triangle, long leg is y, short leg is 5. Medium triangle, long leg is 8, short leg is y. Hey, we're in business. We've got the long leg and the short leg. Notice I cannot even bother with that large triangle. It's not even worth looking at because I don't know either leg. Right? On the large triangle, I know the hypotenuse is 13. Right? 5 plus 8 is 13. But I don't know either leg, so large triangle wouldn't do me any good. Okay, so let's take a look at comparing the long legs and the short legs on the small and medium triangle. So I'll take the small triangle's long leg, compare it to the medium triangle's long leg. That has to have the same ratio as the small triangle's short leg compared to the medium triangle's short leg. So I set up my proportion, plug in the values, and here's where the twist is coming from. Look what happens when we cross multiply. Y times y gets me y squared. So if y squared is 40, I need to take the square root. So notice I multiplied the two numbers together, and then I got to take the square root. Largest perfect square that is a factor of 40 would be 4. And so there I've got an answer. We just found a geometric mean. Right? For an arithmetic mean, you would add numbers and then divide. Instead, with a geometric mean, we multiply numbers, then take a square root. Right? So the geometric mean. Right? If I've got two numbers, notice they both have to be positive. Multiply the numbers together. Take the square root. It's the geometric mean. Right? Arithmetic mean is when you would add and then divide. Geometric mean, you multiply, then take the square root. All right, so let's try a couple. 3, 12. Okay, so what would be the mean? Well, 3 times 12 is 36. Square root of 36 is 6. There's the answer. How about 6 and 15? Well, 6 times 15 is 90. And I'm thinking, what, 9 times 10 for 90? Square root of 9 is 3. Square root of 10, well, I'm stuck with that. How about 12 and 15? Here's another example. 12 times 15 is 180. Now, I could do a guess and check approach. I could try to list every combination. But instead, I'm going to go to the factor tree. I'm thinking, you know what? If I make a factor tree, I'll just keep going here until I have nothing but prime factors. I'm taking all the guesswork out of this. I can see that I've got a pair of 2s, and I've got a pair of 3s. And then there's a leftover 5. So 2 times 2 times 3 times 3 makes 36. So I want 36 times 5. Square root of 36 is just 6. Square root of 5 we're stuck with. Now you don't have to use a factor tree, but I don't think too many of us, when we see 180, are going to immediately think 36 times 5. Right? You might try 10 times 18. Can't take the square root of either one. You might try 9 times 20. Yeah, you can take the square root of 9, but then you still got the square root of 20 you have to work with. So I just like the factor tree method when I get some of the larger numbers and it's maybe not so obvious what the largest perfect square would be. So we're going to have a worksheet. And I don't see anything about an IXL showing up. So today it is only a worksheet.